Welcome to week 5. This week we will start on chapter 20, Chemical Texturizing Services. First we'll discuss permanent waves, and in week 6 we will follow up with relaxers. Why should we study chemical texture services? These services allow stylists the opportunity to offer clients options to change the texture of their hair and explore the fashionable world of hairstyling. Knowing how to perform these services accurately, safely, and professionally will help build a trusting and loyal clientele while aiding in building your confidence to offer chemical texture services to all clients. Chemical services are among the most lucrative and repetitive services in the salon, and many retail products are specific to hair's texture and condition. Without a thorough understanding of chemistry, cosmetologists could damage hair, cause hair loss, and harm their clients and themselves. Upon completion of this week's lesson, you will be able to explain the 4 chemical reactions that take place during permanent waving, explain the difference between an alkaline wave and a true acid wave, explain the purpose of neutralization in permanent waving, and demonstrate safe and effective perm techniques. What is chemical texture services? These are hair services that cause a chemical change that alters the natural wave pattern of the hair. Permanent waving is adding wave or curl to the hair. I want you to take a moment and analyze the texture of your hair. I want you to check your hair in different areas of your head to determine if the texture all around the head is the same or if it varies. I also want you to note your findings in this section of Blackboard, along with the next questions. Have you ever considered having or have you had a chemical texture service? And if you have, what was that service? Why did you want that service? What made you get that service? How did it change the look of your hair and your hairstyle? Did you like the chemical service you received? Was it what you expected? Make sure that you note these answers in this section of Blackboard. All chemical texture procedures involve chemically and physically changing the structure of the hair. Chapter 20 begins by reviewing the structure and purpose of each layer of the hair. Characteristics of hair that were first discussed in Chapter 11, properties of the hair and scalp. The cuticle is the tough exterior layer of the hair. It surrounds the inner layers and protects the hair from damage. Although the cuticle is not directly involved in the texture or movement of the hair, texture chemicals must penetrate through the cuticle to their target in the cortex in order to be effective. The cortex is the middle layer of the hair, located directly beneath the cuticle layer. The cortex is responsible for the incredible strength and elasticity of human hair. Breaking the side bonds of the cortex makes it possible to change the natural wave pattern of the hair. The medulla is the innermost layer of the hair, often called the pith or core of the hair. The medulla does not play a role in chemical texture services and may be missing from fine hair. The importance of pH in texture services. pH is an abbreviation for potential hydrogen. The symbol pH represents the quantity of hydrogen ions. The pH scale measures the acidity and alkalinity of a substance by measuring the quantity of hydrogen ions it contains. The pH scale has a range from 0 to 14. pH of 7 is neutral, the pH below 7 is acidic, and the pH above 7 is alkaline. The natural pH of hair is between 4.5 and 5.5. Chemical solutions raise the pH of the hair to an alkaline state. This action opens the cuticle layer of the hair and allows the solution to reach the cortex layer, where restructuring occurs. Coarse, resistant hair with a long, compact cuticle layer requires a highly alkaline chemical solution. Porous, damaged, or chemically treated hair requires a less alkaline solution. Now we're going to go over the building blocks of hair. First, we have amino acids, which are compounds made up of carbon, oxygen, hydrogen, nitrogen, and sulfur. Next, we have our peptide bonds, also known as end bonds, are chemical bonds that join amino acids together end to end in long chains to form a polypeptide chain. Polypeptide chains are long chains of amino acids joined together by peptide bonds. Next, we have keratin proteins. These are long, coiled polypeptide chains. Side bonds are disulfide salt and hydrogen bonds cross-link polypeptide chains together. Keratin proteins are made of long chains of amino acids linked together end to end like beads. The amino acid chains are linked together by peptide bonds or end bonds. These chains of amino acids linked by peptide bonds are called polypeptides. Keratin proteins are made of long, coiled polypeptide chains, which in turn are comprised of amino acids. Now we'll go over side bonds. The cortex is made up of millions of polypeptide chains cross-linked by three types of side bonds. Disulfide bonds are strong chemical side bonds formed when the sulfur atoms in two adjacent protein chains are joined together. Although they are far fewer disulfide bonds than hydrogen or salt bonds, they are the strongest of the three side bonds, accounting for about 1/3 of the hair's overall strength. Salt bonds are relatively weak physical side bonds that are the result of an attraction between negative and positive electrical charges, ionic bonds. They are easily broken by changes in the pH, and they reform when the pH returns to normal levels. Salt bonds are broken by changes in pH levels. Even though salt bonds are far weaker than disulfide bonds, the hair has so many salt bonds that they account for about 1/3 of the hair's total strength. Last, we have hydrogen bonds. These are weak physical side bonds that are also the result of an attraction between opposite electrical charges. They are easily broken by water, like wet setting, or heat, like thermal styling, and they reform as the hair dries or cools. Although individual hydrogen bonds are very weak, there are so many of them that they too account for about 1/3 of the hair's total strength. Permanent waving is a two-step process whereby the hair undergoes a physical change caused by wrapping the hair on perm rods. The hair then undergoes a chemical change caused by the application of permanent waving solution and neutralizer. When performing a permanent waving service, the size of the rod determines the size of the curl. The shape and type of curl are determined by the shape and type of rod and the wrapping method used. Selecting the correct perm rod and wrapping method is crucial to creating a successful permanent wave. Perm rods come in a wide variety of sizes and shapes that can be combined with different wrapping techniques. Now we're going to get into the chemistry of permanent waving. Alkaline solutions soften and swell the hair and open the cuticle. See the figure illustrating hair saturated in an alkaline solution for 5 minutes, showing the swelling of the cuticle. Conversely, see the second figure to see hair saturated in an acid-balanced solution for 5 minutes. Note there is far less swelling. Once in the cortex, the waving lotion breaks the disulfide bonds through a chemical reaction called reduction. A reduction reaction involves either the addition of hydrogen or the removal of oxygen. The reduction reaction in permanent waving is due to the addition of hydrogen. Thioglycolate acid is a colorless liquid with a strong, unpleasant odor. It is the most common reducing agent in permanent wave solutions. The strength of the permanent waving solution is determined primarily by the concentration of thio. Stronger perms have a higher concentration of thio, which means that more disulfide bonds are broken compared to weaker perms. In addition of ammonia, the thioglycolate acid produces a new chemical named ammonium thioglycolate, which is alkaline and is an active ingredient or reducing agent in alkaline permanents. Coarse hair with a strong resistant cuticle layer needs the additional swelling and penetration that is provided by a stronger and more highly alkaline waving solution. By contrast, porous hair and hair with a damaged cuticle layer is easily penetrated and could be damaged by a highly alkaline permanent waving solution. The alkalinity of the perm solution should correspond to the resistance, strength, and porosity of the cuticle layer. A variety of permanent waves are available today. This chart depicts how perms can vary from being acid-balanced to highly alkaline, depending on the type and formulation. Alkaline waves were first developed in 1941 using ammonium thioglycolate, ATG. They became known as cold waves since they process at room temperature without adding heat. They usually have a pH between 9 and 9.6. In acid waves, glyceryl monothioglycolate is the main ingredient in true acid and acid-balanced waving lotions. It has a low pH and is the primary reducing agent in most acid waves. True acid waves were introduced in the early 1970s. They usually have a pH of 4.5 to 7 and require heat to speed processing. They have 3 separate components: waving lotion, activator, and neutralizer. The activator tube contains GMTG. Acid waves process more slowly and do not produce a firm curl as alkaline waves. Exothermic waves are perms that create an exothermic chemical reaction that heats up the solution and speeds up the process. All exothermic waves have 3 components: permanent waving solution, activator, and neutralizer. Endothermic waves are perms that are activated by an outside heat source. usually a conventional hood dryer. They will not process properly at room temperature. Ammonia-free waves are perms that use an ingredient that does not evaporate as readily as ammonia, so there is very little odor associated with their use. AMP and MEA are examples of alkyl amines that are used as substitutes for ammonia. Odor is reduced, but damage can still occur. Thio-free waves use an ingredient other than ATG, such as cristamine or mercaptamine, as the primary reducing agent. Even though these thio substitutes are not technically ATG, there are still thio compounds. Although thio-free wave products are often marketed as damage-free, this is not necessarily true. At a high concentration, the reducing agents in thio-free waves can just be as damaging as thio. Low pH waves are perms that use sulfates, sulfites, and bisulfites present an alternative to ATG. Sulfites work at a low pH. Permanents based on sulfites are very weak and do not provide a firm curl, especially on strong and resistant hair. Sulfite permanents are usually marketed as body waves or alternate waves. It is important to select the right type of perm for each client. Each client's hair has a distinct texture and condition, so individual needs must always be addressed. After a thorough consultation, you should be able to determine which type of permanent is best suited to your client's hair type, hair condition, and desired results. This table shown here lists the most common types of permanent waves, along with selected advantages and disadvantages for each. These are only general guidelines. Just because a perm is indicated for use on color-treated hair does not mean it is safe for damaged or bleached hair. Also, hair that has been treated with a semi-permanent color, which coats the hair, is more resistant than and not as porous as hair treated with permanent color. Processing a permanent wave. The strength of any permanent wave is based on the concentration of its reducing agent. In turn, the amount of processing is determined by the strength of the permanent wave solution. The amount of processing should be determined by the strength of the solution, not necessarily the perm's processing time. Most processing takes 5 to 10 minutes. Additional time allows polypeptide chains to shift to a new configuration. Overprocessed hair does not mean overly curly. If too many disulfide bonds are broken, hair will be too weak to hold a firm curl. It may be completely straight. Hair at the scalp is usually stronger than at the ends, so overprocessed hair is usually curly at the scalp and straighter at the ends. Underprocessed hair is too few disulfide bonds are broken, the hair will not be sufficiently softened and will not hold the desired curl. Hair at the scalp is usually not as curly as at the ends. More processing will make it curlier. Neutralization is the process of stopping the action of a solution and hardening the hair in its new form. It deactivates waving solution should any be left in the hair. It rebuilds the disulfide bonds into the new shape. Neutralizers are oxidizers. The most common neutralizer is hydrogen peroxide. Concentrations vary between 5 volume, which is 1.5% hydrogen peroxide, and 10 volume, which is 3 hydrogen peroxide. Stage 1 of neutralization, the first function is deactivation of the waving solution that remains in the hair after rinsing. You want to rinse the hair for full 5 minutes. Towel blot thoroughly. You blot each rod several times using dry towels. If directed, apply a pre-neutralizing conditioner. An acidic liquid protein conditioner can be applied to the hair and dried under a warm dryer for 5 minutes or more prior to neutralization. This is beneficial for damaged hair. Always follow the manufacturer's directions. Next are listed the proper rinsing and blotting procedures. First, you want to rinse with warm water. You want to always use a gentle stream of water. Avoid pressure on rods while rinsing. Rinse the most fragile areas first. Thoroughly rinse the nape area and rod bottoms. Rinse for the recommended time. Smell the hair and continue to rinse if the odor is still present. Gently blot the hair with a towel with each rod, rotating that rod up so we blot the top of the rod and the bottom of the rod. Check for excess moisture, especially at the nape. Adjust any loosened or drifted rods. The second stage of neutralization, the disulfide bonds are broken. Waving lotion breaks disulfide bonds by adding the hydrogen atoms to sulfur atoms in the disulfide bonds. Disulfide bonds are then rebuilt. Thioneutralization rebuilds disulfide bonds by removing extra hydrogen atoms. Hydrogen bonds attract oxygen. Hydrogen atoms attract to oxygen in the neutralizer and release their bond with the sulfur atoms and join with the oxygen. A water molecule is formed. Each oxygen atom joins with 2 hydrogen atoms to rebuild one disulfide bond and make one molecule of water. The water is removed. Water is removed in the final rinse and the disulfide bonds form in their new curled position. Side bonds are reformed. Side bonds are reformed into their new shape as a different pair. Most processing takes 5 to 10 minutes. Additional time allows polypeptide chains to shift to a new configuration. A preliminary test curl is performed and is used to determine how the hair will react to a perm. You want to take note, correct processing time is used to determine best processing time for best curl development. The expected results from the solution, the curl expected from rods and wraps, how much color will be removed from the process if the client has color-treated hair, will the integrity of the hair be compromised, did the hair break, is it dry, is it frizzy, is the client satisfied with the shape and hold of the curl. These are all things you need to take note of when performing a preliminary test curl. Now we're going to go over types of rods. Here we have a concave rod, which is most common. They have a smaller circumference in the center and a larger circumference on the ends They produce a tighter curl in the center and a looser, larger curl on either side of the strand. Our straight rods have equal diameter along the entire length of the rod, or curling area. They produce a uniform curl along the entire width of the strand. Concave and straight rods come in a variety of lengths to accommodate different sections of the head. Next we have soft bender rods. These are usually about 12 inches long with a uniform diameter along the entire length. They are soft foam rods with a stiff inner wire that allows them to take on a variety of shapes. Next you have loop rods, also known as circle rods. These are usually about 12 inches long with a uniform diameter. They are ideal for wrapping extremely long hair. When fastened together, they form a circle. Now we'll take a look at this diagram. It shows the curl or wave produced depending on the size of the rod. If you notice, the smaller rods, the 3/8 of an inch, produces a tight, kinky spiral curl, whereas the 1.5 inch rod produces a large, voluminous curl, which is almost a wave. Here are 5 types of perms to choose from. The top perm, you have a spiral. It results in ringlets that are basically extremely tight curls. The size of the curls vary based on the size of the perm rod. Next, you have gentle waves. It is created using large rollers. It adds volume to the hair, making it look naturally soft and wavy. Next, we have a root perm. This is only the roots that are permed, making your mane look voluminous. This is a perm meant for short hair if you want to go retro. It also works wonders on limp, flat tresses. Your fourth perm is a body perm. It is a result of large, loose, cascading curls, meant especially for thin, fine, and sleek hair. It gives body to your locks, and it helps soften sharp boy facial features. Next is a multi-textured perm. 2 different size rods are used, so the curls vary in size throughout. It looks more natural as opposed to other perms. It suits women with long hair the best, not so much if you have short hair. Also known as end wraps, end papers are absorbent papers used to control the ends of the hair when wrapping. When wrapping, paper should extend beyond the hair ends, keeping them smooth and straight, and to prevent fish hooks, which is hair that is bent at the ends. First you have a double flat wrap. This uses 2 end papers, one placed under and one over the hair strand. Both papers extend past the hair ends. Next you have a single flat wrap. This uses 1 end paper placed over top of the strand of hair being wrapped. Lastly, we have a bookend wrap. This uses 1 end paper folded half over the hair ends like an envelope. Pre-folded wraps are large end papers which can be folded are available. This eliminates excess paper, and they can be used with short rods or with very short lengths of hair. The size, shape, and direction of panels varies based on the type of wrapping pattern and type and size of the tool being used. Panels are divided into subsections called base sections. One tool is placed on each base section. The size of the base section is usually the length and width of the tool being used. Base placement refers to the position of the rod in relation to its base section. This is determined by the angle at which hair is wrapped. On base placement is when the hair is wrapped at an angle of 45 degrees beyond perpendicular to its base section. The tool is positioned on its base section. Half off base placement is when the hair is wrapped at a 90-degree angle perpendicular to its base section. The tool was positioned half off its base section. This positioning minimizes stress and tension on the hair. Off-base placement is when the hair is wrapped at an angle of 45 degrees below perpendicular to its base section. The tool is positioned completely off its base section. This creates the least amount of volume and the curl pattern begins away from the scalp. Base direction refers to the angle at which the tool is positioned on the head, horizontally, vertically, or diagonally. It also refers to the directional pattern in which the hair is wrapped, backward, forward, to one side, and so on. Wrapping against the natural growth pattern causes excess stress that may damage or break hair. Now we're going to talk about wrapping techniques. The first technique we'll talk about is crokinole. This is where the hair strands are wrapped from the ends to the scalp in overlapping concentric layers. The curl is tighter on ends and gets larger near the scalp. Next is a spiral technique. The hair is wrapped at an angle other than perpendicular to the length of the rod, which causes the hair to spiral along the length of the rod, like the stripes on a candy cane. A spiral perm wrap may partially overlap the preceding layers. As long as the angle remains constant, any overlap will be uniform along the length of the rod and the strand of hair. This wrapping technique causes the size of the curl to remain constant along the entire length of the strand and produces a uniform curl from the scalp to ends. Next we have double rod wrap and a basic perm wrap. The double rod wrap, also known as piggyback, are used for extra long hair. The hair is wrapped on one rod from the scalp to midway down the hair shaft, and the other rod is used to wrap the remaining hair strand in the same direction. This allows for better penetration of the processing solution and for a tighter curl near the scalp than that provided by a conventional crokinole wrap. The basic perm wrap is also known as a straight set wrap. It is a wrapping pattern in which all of the rods within a panel move in the same direction and are positioned on equal-sized bases. All the base sections are horizontal and are the same length and width as the perm rod. Next we have base control. This position of the tool in relation to its base section determined by the angle at which the hair is wrapped. Also, curvature perm wraps are partings and bases radiate throughout the panels to follow the curvature of the head. This wrapping pattern uses pie-shaped base sections in the curvature areas. Partial perms and men's perms. If your client wants a perm but does not wish the entire head of hair to be curled, a partial perm may be the answer. Partial perms also allow you to give a perm when some of the hair is too short to roll on rods. It can be used for male and female clients who have long hair on the top and crown, but very short hair with tapered sides and nape. Clients who will only need volume and lift in certain areas, and clients who desire a hairstyle with curls along the perimeter, but a smooth and sleek crown. Additional considerations for partial perms rely on the same techniques and wrapping patterns as those used with other perms, but there are additional considerations. Smooth transitions between sections. In order to make a smooth transition from the rolled section to the unrolled section, you want to use a larger rod for the last rod next to the unrolled section. Also protect the unrolled hair. Applying waving solution to unrolled hair may straighten it or make it difficult to style. To protect the unrolled hair, apply protective barrier cream to the unrolled section before applying the waving lotion. Many male clients are looking for added texture, fullness, style, and low maintenance that only a perm can provide. Perms help thin hair look fuller, make straight or coarse hair more manageable, and help control stubborn cowlicks. Although men's and women's hairstyles may be different, the techniques for permanent waving are essentially the same. Some home hair coloring products contain metallic salts that are not compatible with permanent waving. Metallic salts leave a coating on the hair that may cause uneven curls, severe discoloration, or hair breakage. Metallic salts are more commonly found in men's hair colors that are sold for home use. To test for metallic salts, in a glass or plastic bowl, you want to mix 1 ounce of 20 volume peroxide with 20 drops of 28% ammonia. Then you'll immerse at least 20 strands of hair in the solution for 30 minutes. If metallic salts are not present, the hair will lighten slightly and you may proceed with the service. If metallic salts are present, the hair will lighten rapidly. The solution may be hot and give off an unpleasant odor, indicating that you should not proceed with the service. Lastly, we'll discuss perm safety precautions. First, always protect the client's clothing. Have the client change into a gown or use a waterproof cape and double drape with towels to absorb accidental spills. Beware of previous allergies. Do not give a permanent to any client who has experienced an allergic reaction to a previous perm. Complete a hair and scalp analysis. Always examine the scalp before the perm service. Do not proceed if there are any skin abrasions or sign of scalp disease. Check for damage. Do not perm hair that is excessively damaged or shows signs of breakage. Do not perm relaxed hair. Do not attempt to perm hair that has been previously treated with hydroxide relaxers. Check for metallic salts. If there is a possibility that metallic hair color has been previously used on the hair, perform a test for metallic salts. Use protective cream. Always apply protective barrier cream around the client's hairline and ears prior to applying permanent waving solution. Use as directed. Do not dilute or add anything to the waving lotion or neutralizer unless it's specified in the manufacturer's directions. Keep waving lotion out of the client's eyes. In case of an accidental exposure, rinse thoroughly with cool water. Always, always, always follow the manufacturer's directions. Be sure to wear gloves when applying solutions. Immediately replace cotton or towels that have become wet with solution. Do not save any opened, unused, waving solution, or neutralizer. When not used promptly, these chemicals may change in strength and effectiveness. Hair that has been permanently waved should be shampooed and conditioned with products formulated for chemically treated hair. This concludes Week 5, Chapter 20, Chemical Texturizing, Permanent Waving, PowerPoint. Please complete your Blackboard assignments and submit to me. Thank you all, and have a good week.